Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Analyze molecule A 1,3-dichloroline HCl. C is equal to C is equal to C HCl. In allenes, the two end groups are in perpendicular planes. The two terminal carbons each bear H and Cl. Because the substituents on each terminal carbon are different, H is not equal to Cl, and the two planes are perpendicular, the molecule is chiral, axial chirality. However, there is no classical chiral carbon, sp3 carbon with four different groups. The central carbon of the allene is a stereocenter, axial stereocenter stereoaxis. The molecule is optically active, it exists as non-superimposable mirror images. It has a stereocenter, the allenic axis counts as a stereocenter, but no chiral center in the classical sp3 sense. Therefore, A matches Q presence of stereocenter and R optically active compound. Answer AQR. Moving on to the next step. Analyze molecule B trans 2-butene shown in Sohor's projection with H and CH3 on each carbon of the double bond in trans arrangement. The C is equal to C double bond carbons are stereocenters, geometric stereocenters. The molecule is trans 2-butene. It has a plane of symmetry, the plane bisecting the molecule perpendicular to C is equal to C axis, or the molecular plane itself gives symmetry making it a chiral. It is not optically active. It has stereocenters. The sp2 carbons bearing different groups qualify as stereocenters in the context of EZ isomerism. It has no chiral center, no sp3 carbon with four different groups. Therefore, B matches Q presence of stereocenter and S compound containing plane of symmetry. Answer BQS. Moving on to the next step. Analyze molecule C carbon bearing four different substituents Cl, Br, F, I. This is a classic chiral center, one sp3 carbon bonded to four different atoms groups. It has a chiral center P, it has a stereocenter Q, and it is optically active R since it has no internal plane of symmetry and the compound, as a single enantiomer, rotates plane polarized light. Therefore, C matches P, chiral centers containing compound, Q presence of stereocenter, and R optically active compound. Answer CPQR. And for the final step. Analyze molecule D oxime of methyl ethyl ketone CH3 at C is equal to NO with lone pair on N. The nitrogen in the oxime C is equal to NO bears, the C is equal to N bond, O, and a lone pair. In oximes, it is considered a stereocenter because it has three different groups plus a lone pair, similar to sp3 nitrogen but with restricted inversion due to the C is equal to N double bond. The nitrogen atom in an oxime is a stereocenter, EZ isomerism at C is equal to N. The molecule can have E and Z forms. The carbon bearing CH3 and it has only two different groups, plus is equal to N, so it is not a classical chiral center. However, the N is a stereocenter. The molecule, either E or Z isomer, has a plane of symmetry. Actually for CH3 at C is equal to NO, the two groups on carbon are different, CH3 is not equal to it, giving EZ isomers, and the nitrogen is the stereocenter. Each isomer, E or Z, has a plane of symmetry within the molecular framework, the plane of the C is equal to NO system. The molecule is achiral, has plane of symmetry, and not optically active, but has a stereocenter, N. Therefore, D matches Q presence of stereocenter and S compound containing plane of symmetry. Answer DQS. Therefore, The correct answer is AQ, R, BQ, S, CP, Q, R, DQ, S. The correct answer is shown on screen.